Well, hello everyone, and welcome to another ATLIS webinar. I'm Kelsey Watson, Senior Director of Membership and Marketing at ATLIS, and I am thrilled to have Pete Russell and Erin Hammond here from August Schools. They're here to talk to you about August Intelligence, the first AI agent designed specifically for the school environment. So without further ado, I'm going to hand it over to Pete and Erin. Thank you so much for your support of ATLIS. Can't wait to hear what you have to say.
Thanks, Kelsey. Really appreciate it. And thanks so much for everyone joining live. Really nice to have you all here. I'm Pete Russell. I'm the CEO of August Schools. I see some familiar names here, so I hope there's some familiarity. Erin, you want to introduce yourself?
Yeah, totally. So my name's Aaron Hammond. I'm the CTO of August Schools. Really excited about all this AI stuff, and I'm really excited to show you guys what we have ready.
Yeah, so I think a fair amount of you probably know August Schools, but I want to give a little bit of context about the company, why we started building with AI, and I think some of that pretext is helpful. So if you haven't heard of us, August Schools is the operating system for student support. So our data intelligence, documentation, and communications platform is currently in use in independent schools across the country. Folks use us for everything from keeping track of critical mental health notes. We have a robust electronic health record system. So if you don't have a formal system of record for your counselors, you should definitely be already working with us. If you're unhappy with your current EHR vendor, we should definitely be in touch. But we do a lot more than that. Also, we work with learning specialists, we work with school administrators, and as we turn toward AI, we're really, we started building these tools for our current user base, but very quickly it's become apparent how useful and powerful these tools are beyond the support umbrella. And I think you'll get a sense of that pretty quickly here. So I'm going to go ahead and walk through some use cases, walk through some basics about how the product works, and then Erin's going to double click and show you what's under the hood. I know we have a technology heavy crowd here, so we're going to walk through some of the details about how this works, and I hope you find it interesting because a lot of this stuff is really cutting edge, and it is really, really neat tech. So I'll go ahead and share my screen, get started, and we're going to leave. There's going to be plenty of time for questions, and I do expect some of the natural questions that will come up will get answered along the way. So you should be able to see my screen now. So I'm in the content bank that the assistant has access to. And first and foremost, I can select information that currently lives in August Schools or currently lives in the student information system and kind of give access to the assistant for that data. I can also upload content of whatever type directly into the assistant here. We have a really robust role-based access system. And so we have school counselors, school nurses, people who deal with some of the most sensitive information at a school in our system. So partitioning that data and maintaining certain important overlaps, we call them interlocking circles of trust, is a really important part of our platform. Importantly, that percolates into the assistant. So the way, basically, as a user, I have access to certain information in August Schools. If I activate the assistant or my school activates the assistant only has access, my assistant only has access to the information that I as a user have access to. So it respects that role-based system. Erin's going to talk through how we do that because it's pretty cool. So I'm going to just jump right in and start walking through use cases. And for the sake of being provocative, I'm going to start with one that's a little bit outside. It's looking at student information system data rather than strictly August Schools data. one of our goals for this conversation and a lot of the conversations we're currently having with customers and prospects is showing people the skills of this tool and helping people dream on what's possible based on the problems you have, the data you have, what types of things would you like to unlock with artificial intelligence? I think most of you, I assume most folks have a basic level of understanding about large language models and what their kind of core capabilities are. But a lot of this stuff's new so to just level set a little bit, I think first and foremost, the LLMs, think Llama, think GPT, they're really good at natural language stuff broadly, right? So they're really good at understanding natural language. They're really good at generating natural language. They're really good at looking through large amounts of unstructured data and creating synthesis and meaning. And that unstructured data can be, a ton of natural language. It could be a huge stack of report cards saved as PDFs. Incredibly good at just crawling through information and developing really kind of tidy, meaningful signal out of that. Also really good at kind of just generating high quality written content. And importantly, it helps you just talk to a computer as you would a person. And as you can see on my screen here, that quickly becomes very powerful in a querying use case. As IT folks at independent schools, I'm willing to hazard that you have been asked to build a query for someone at some point, probably more than you ever would have hoped. I talk to a lot of different types of users constantly of student information systems and August schools, and querying interfaces are hard to manipulate. Building this type of stuff is clicky. It's hard. Boolean logic isn't necessarily natural to everyone, but people want to ask complex questions of their data. But the types of users who want to ask these questions, and they have a really sophisticated mental model that they're bringing to the questions they want to ask, don't necessarily have the technical chops to form that into a query that's sensible. So using natural language to build queries is one of the first powers that we gave the agent, because there's so much data in your systems and a lot of frustrated users kind of prevented from getting the signal, insight, and meaning out of that data based on how hard it is to use a standard querying interface. And we know that well. These UIs, like, when you look at this is a pretty simple question, but this is how it tends to manifest. And we've looked at a lot of different query builders and none are perfect. And they're either simple and they don't answer every question, or they get complicated, but they're powerful. So show me students with unexcused absences last week. And bear in mind, I made this a few days ago on the 18th. So it just looks back a week from the 18th and grabs the appropriate attendance record. I wanted it to look at the full calendar week before. So incredibly natural and intuitive to interact with an agent. No, that's not what I meant. Thank you, though. But please show me students with at least one unexcused absence last week between Monday and Friday. It knows what I'm saying just like a person would. It forms that query. Now it's looking back correctly into last week, just like I wanted it to. And it's returning 5 results here. Great. Okay. I want to reach out to these kids' families. We've been talking to a lot of schools who only since COVID have they realized, wow, we all of a sudden have an attendance problem that we never had previously. So this is actually kind of an active case that a few of our schools are working on. So find the contact information for the parents and draft emails to each of the families referencing our attendance policy. I can upload our student handbook into the content store. So when it's referencing an attendance policy, it's referencing my school's attendance policy. Here it is, building a query, just like I asked it to. It's looking directly at those 5 students who had the absences. It's looking through your student information system. It's finding the parents, finding their contact information. And the other skill that we gave the agent right off the top is the ability to send messages directly from the agent experience. When you weave these together, they're very powerful. So it wrote me an email. It found the contact information, but the robot's really, really smart, really precocious, but it's like sometimes it needs a little bit more guidance. No, sorry. Please draft separate emails for each family and populate the parent's contact information. But again, really easy to sort through these unexpected responses. Now it's done exactly what I want. It's populating the parents in for the correct student. It's written a quality email. I can tweak it however I'd like to. I can use a prompt to change all of the emails at once. Once you start having kind of data on the floor in the form of the queries, and once you start having the messages built, you can really just start manipulating it, and really the power kind of increases as the conversation goes on. So really, really neat stuff here. Let me just ask kind of which classes had the most unexcused absences in January 2025? I'll shoot that message off and let it think of a little bit. So the next case I want to show you is the robot actually making a deliverable and a report based on the queries that I'm sending it. So let me find that thread that I've already created. So I'm going to come back to that thread. The LLM's thinking about that last answer. Here's another one I kicked off here in preparation for this call. So I'm asking a really general question about health in January 2025. There are certain cases where based on the data in our system and the core types of questions that get asked again and again, you can ask these kind of big questions and it will automatically create queries that unpack the detail that folks tend to want to know about that type of question. Health has been a really important use case for us over time. So when I ask it a kind of big picture health question, I actually get really kind of intentional queries here. So it's asking, here are my chief complaints over the course of that month. Here are my clinic dispositions over that month. Here are the encounter notes. So it's grabbing a ton of data that's then informing this summary report that it's stringing together here. So nicely formatted, comes with a very reasonable framework. It's a pretty solid report just on its first try. I want more data in it though. I want more tallies. I want more statistics. So I'll just ask it to update it using more tallies. Does exactly what I ask. But now it's getting a little bit long. I think I like it to be more summary level. So natural. Make it shorter. Great. It does that. Makes it tidier again. Lost the numbers. Put back the numbers. Great. Cap it at 5 entries. Very, very easily. I've now come to what's a really nice report that I'm happy to share with my colleagues, share with my boss. I can extend it also. I want to celebrate the user who basically took the most actions during that month. I just asked, please add a note to the top celebrating the user who created the most encounters that month. In one step, I ask that question and it does both of the things at once. First, it gathers the data it needs to answer that question. And by the way, each of these charts, each of these queries, they come with visualizations. This is a little bit insane because it's based on our seed data, not necessarily very realistic. I can also save any of these queries I've built into the core querying and reporting system. So natural interconnections to the rest of the application. but really nice. Adds that note I asked it to right at the top. Okay, I like it. I'm gonna go ahead and put this into an August message to send directly to my colleague Aaron. Aaron. Um, Looks like in the background, cooked up what the classes with the most unexcused absences were in January. You can see right in that summary that it did the exact right thing I wanted it to. Here's a nice visualization I can grab. I can elect to show the data here, and then gives you this nice summary table as well. I can really, we're early days with some of the data analysis piece, but the the LLMs also know math. And Aaron's going to show you the different LLMs we're using, and some are better at math than others. They're also getting a lot better at math really quickly. So this stuff's just kind of fun. You'll notice there are a couple of weird things that we're working on how we represent math, like in a cute way. But we've just been having fun with this stuff, frankly. So I can query data, and then I can do data analysis on top of it, all within the application. So again, pulling down some queries, and that's a more sensible looking chart. So calculate the average number of encounters by student race. This is the only prompt I gave it. It grabbed the data it needed. So all encounters, all students, both broken down by racial groups, goes ahead, does that fractional math. Perfect. Okay, are any of those outliers? Some more sophisticated math. Quickly testing my math skills, not Aaron's, but okay, it went ahead. It just chose a method. It chose the IQR method to go about doing that calculation. Ran all the way through it, and not finding any outliers. I do know enough to know that standard deviations, kind of standard way of understanding this. What about using a standard deviation method? All I need to do, it runs through the math, and using the standard deviation method, it's actually showing that there is an outlier group. Nice little summary down here. So in terms of querying data, as a user who might have historically needed to bother someone in IT to get the answer that they want to get, or more often than not, they just don't necessarily kind of do the data analysis that they want to do because they're not an analyst and building queries is hard. Now it's just, I'm using natural language, asking for the information I need, pulling that down, doing further analysis on top of it, creating a high quality deliverable. It's when you start stacking these skills on top of each other, it gets neater and neater. So let me show another case. Yeah, this is a fun one, or the topic isn't fun, but the technology is interesting. So I'm asking if any students are experiencing bullying, and most of our clients, they don't call what when I was a kid they called it bullying. Call it a harm incident is typically how our counselors talk about these things, and there there's a whole backstory, and it's really kind of, I think it's really cool that we no longer typecast certain students as bullies. Anyway, so if I ask about bullying, but bullying's not a field in our system that can be queried, the agent kind of takes off its scientist hat. It's like, I can't give you a precise query about that thing because that's not a field in our system, but I'm a large language model that's been trained on a lot of general information, and I know what bullying means. And I know the kind of constellation of behaviors that is typically described as bullying. And I'm going to crawl through all the unstructured information in the system and identify and reference different possible instances of bullying. So that ability to just crawl through massive amounts of unstructured information is extremely powerful. We have a lot of counseling clients who do a great job of structuring certain fields, but inevitably a lot of information in that context gets captured in unstructured ways. And then you want to just do recall. You want to ask what happened, and the agent gives you the ability to do that. furthermore, a classic example, okay, I want to reach out to the faculty advisors for these students. I want to check in with them. Again, we have all of that data in our system directly from the student information system. Looks like it drafted these without the contacts, which no big deal. I'll just explicitly ask it to find the faculty advisor. It does that quite nicely, grabs them all appropriately. Now it's going to send the message with the correct folks in here. So an example of kind of, it can look for information in a very structured way. It can also look for information in a very unstructured way. Stacking on top of this, okay, have any of these kids not met with a counselor this year? And now it's just running a very simple query. That kid, do they have any, what's their encounter count with a counselor? So cobbling together the kind of, the type of answer you might get if you asked a person, hey, what do you remember about this student? What's the pattern you're seeing in the student? And then you can marry that with the scientist. Okay, no, I want you to be extremely careful, with the health instances. When I ask about students with allergies, I need to make sure that I'm not getting a hallucination. Erin's going to walk through kind of how we make the querying language very, very accurate, despite certain kind of large language models' propensities to make things up when they're not sure. We have some really neat stuff going on under the hood so that you can trust it in cases that are extremely important and involve health and other things. So I'm kind of shocked by how much time is going on. So let me jump into another very different type of example, and then we can walk through the schematic and see what kinds of questions folks have. But this is a different kind of case. Where like the LLMs are trained on massive amounts of information, right? So it has a lot of general knowledge, which is extremely helpful. If I want to specify any given thing, like if I ask it about restorative justice, it'll give me what it knows about restorative justice from its broad range of training materials. I can also upload a restorative justice toolkit. I have done that, which is why I picked that example, that it will reference that particular document and give it primacy in its answers. So as you think about kind of layering on school policy as a context here, it's really powerful, but it's awfully cool also to just ask kind of the whole internet effectively a question. So what are common assessments used for mental health? I think it's really helpful to see how it acts here. So first of all, it actually looked through the counselor I'm logged in as data and found some mental health assessments that person had run with students. But that's not what I want to know. Besides what you've seen in the documents, kind of in the content store I showed you, what do you know? What are common assessments for mental health based on your knowledge as kind of a short form way of getting the robot to look outside the content store to its general knowledge? Does exactly what I ask, finds these common assessments. This stuff is just cut through and useful and practical for a wide variety of users and really helpful for folks trying to steer people through certain knowledge paths to be able to pre-populate their content store with the kind of context you want them to have. Use self-report is one of these. I ask it to summarize it. This is all just general knowledge that the LLM was pre-trained on. This isn't information that was uploaded manually. I can create an example questionnaire. It just has this off the top of its head, really powerful stuff. Now I can say, this one's actually kind of an impressive query. Based on what the YSR is meant for and what you know about our students, which students might benefit from having one administered? That's the only prompt here. And based on its context, it's going through and it's identifying students with different kinds of conditions and folks who are seeing the counselor, which is a very reasonable kind of first pass on this, and I can make it more and more specific if I'd like to. So again, building queries using natural language, using natural language prompts to crawl through large amounts of unstructured data, to kind of retrieve summary information, to retrieve kind of synthesis, generating natural language, generating natural language communications that can be sent directly from the product. And also all of the general knowledge that the LMs are trained on is all kind of out of the box right now. We're giving it a lot of skills really rapidly. And the key part of our roadmap right now is just giving it more and more signal, more and more data to interact with. So really, student information system data is where we're looking. So academics, we have kind of in the pipeline right now, mostly working some interesting stuff in that data that maybe Aaron will reference. But attendance, we've been hearing so much about how hard it is to query that information, and it's really been top of mind for a lot of our divisional heads we've been talking to recently. So that's why we started there. So much more to come. But I think there are a lot of natural questions that come up, a lot of natural concerns, privacy concerns that come up. So Aaron, if you could walk through your schematic about kind of how this works under the hood, how we can do this in a way that's extremely safe. And I think it's worth saying at the top, the data is not being used to train these models. But please, if you could unpack this a little bit for our IT audience here, that'd be great.
Yeah, totally. So yeah, again, my name's Aaron Hammond. I'm the CTO of August Schools. We've been working on this technology for about 1.5 years now, kind of putting all the pieces together. So it's been a huge effort on our part. Super excited to kind of lift the curtain a little bit and show how it's working under the covers. So I guess the first thing that I just want to call out here, so, wherever you saw those little green squares kind of in the chat message, so that's representing a query kind of in our system. And those queries are written using a proprietary query language that we call AugQL, which stands for, of course, August query language. So AugQL is really like the special sauce here that kind of makes this agent really sing. So AugQL is, you can kind of think of it as like an intermediate layer between kind of low-level database query languages, like you might think about SQL, or if you're using MongoDB, like a MongoDB aggregation. It's bridging between kind of natural language and those low-level database primitives so that the agent can actually execute these queries correctly and consistently and accurately without kind of all of the complication that comes from trying to write a low-level language. So AugQL is super expressive. It allows you to query across multiple collections without really having to think about it. So, a very good example, or a complicated example anyway, here. So if I were to ask the agent, have there been any encounters with students with peanut allergies? The agent is going to construct an AugQL query. So this query will hit encounters, and it's going to be looking for the student subjects of those encounters where they have an allergy that matches an allergen that is within the set of food peanuts. We're also going to simultaneously query over the notes of that encounter, and we're going to be looking at the chief complaints on the notes of that encounter, and we're going to be matching those against another set. And then we're going to be pulling the specific fields that we need. So the agent is able to produce this kind of query in a way that it just can't do with SQL or with Mongo aggregations itself. So the agent is really good at writing this sort of thing because it's natural language inspired. And this will pull kind of exactly, deterministically the data that the agent wants. So to talk about like another example that Pete brought up, the average number of encounters by some characteristic. So in this case, the agent doesn't just have the ability to query data. AugQL also supports a few computational primitives, namely counting and tallying. So in this case, we can answer the question about, what's the average number of encounters with third graders by issuing 2 different count operations. First, we're going to count the number of encounters with third graders, and then we're going to count the overall number of third graders to normalize. So you got your numerator, your denominator there. I think another question Pete asked is, number of unexcused absences by class. So similar kind of question here, are there any outliers among sport teams for the number of encounters? So in this case, we have a tally operation that allows us to tally kind of the names of sport teams for encounters. And then we can also tally the number of students per sport team. So again, we have kind of the numerator and the denominator, so we can figure out the averages per sport team. And then, of course, from there, kind of the agent will use its LLM power to actually do the calculation for the outlier. So the reason I kind of bring this all up is, the problem with hallucination is something that like a lot of folks within generative AI are trying to address right now. Just broadly, what hallucination means is like the agent, like Pete mentioned, it's not sure what to do, so it's going to make something up. AuQL kind of gives it the grounding in reality such that those kinds of hallucinations don't happen. If the agent doesn't know something that it needs to know, it's not just going to throw up its hands and make up an answer. It's going to actually issue the query to get that information so that it can be confident in its decision making. So AuQL is really kind of at the heart of this all. And if you've used our reporting framework at all, Query Builder and everything, that's powered by AuQL. So like AuQL has kind of been in the wild for a couple of years now, and it's gotten quite powerful in terms of what it can do. And we're very confident kind of in its ability as an interface to deliver correct information. And now it's just making the robot kind of even more powerful. So kind of moving on from AuQL. So this is just kind of like a several mile high view of kind of our architecture. But I'm just going to kind of walk through how it works from like an initial user message. So let's say that I ask my agent, who are my students with peanut allergies? So before kind of anything happens, every night we go through this process of what's called chunking and vectorization. So inside of our database, we might have records for each student, right? Every user can't see everything on the student, right? So a counselor may be able to see the counselor-related fields, a nurse may be able to see the health-related fields, but they can't see kind of the whole record just because they're one type of user. So in order to make kind of the role-based access control work here, we split up application records into multiple chunks. So an individual student might get split up into two different chunks. We have our basic information chunk and we have our health information chunk. What's important is these chunks are role-based scoping. So, the basic information chunk, all users may be able to have access to that. But for the health information chunk, only kind of nurses or clinic aides, they should only have access to that data. So kind of each chunk represents kind of an encapsulation of like related content that can be viewed by a particular role set. So once we have these chunks kind of cut up out of the main application records, we go through what's called vectorization. So vectorization, broadly speaking, it's a bunch of fancy math that allows us to go from like a chunk of text into like a vector, so like a string of numbers, basically. And then those vectors themselves have some interesting mathematical properties that allow the agent to kind of do what it does. But the important thing to note here is just we're going from kind of that raw text to a bunch of numbers that represent the raw text for each of those chunks. So once we kind of have that vectorization of each chunk, we're going to store it kind of in our own little chunks database. So returning to my user message, when a user issues kind of a prompt like, who are my students with peanut allergies? The first thing that's going to happen is that message is also going to be vectorized. So we use the same kind of math that we use to turn the chunks into numbers. We use that same math to turn the user's message into numbers. And then, as I said, like the numbers that we transform them into have some interesting properties. And one of them is that for two messages that are related to each other in meaning, so like peanut allergies and tree nuts would be kind of close together because they have similar amount of meaning. So the numbers themselves like, get closer to each other kind of as they become more related in meaning. So it's a little trippy to think about, but the important thing here is that, based upon this message, we're able to find chunks that are related to the content at hand. So, I asked about students with peanut allergies. We're able to identify that health information chunk, that says peanuts, that health information chunk is related to my question at hand. And we do that search using a couple of different methods. Not very interesting, but We look at the cosine similarity kind of between messages. So we look at how close the numbers are once we've done that vectorization. And then we also do a plain text search so that, if you actually say the word bullying, then you're going to kind of come up further in the results for bullying queries. So we use kind of a mixture there to get kind of the optimal kind of outcome. But once we've identified kind of what chunks are related to a user's message, we go through a process of what's called retrieval augmented generation, or RAG. So this is kind of a popular term nowadays. It's pretty straightforward, actually, once you get down to the brass tacks of it. So effectively, what we're going to do is we're going to take these chunks and we're going to combine them with the original user's message, and then we're going to send the whole bundle off to the LLM. So kind of at the other cornerstone of this whole system are these LLMs, so large language models. So as Pete mentioned, these are things like GPT, but there's also a bunch of open source versions of these LLMs. So Llama is published by Meta or Facebook. Mistral is its own kind of independent group publishing LLM models. So we don't bind to a particular LLM. We are what's called multi-model, meaning that we can actually connect to different LLMs depending upon what task we're trying to do. So, there's some tasks that Llama is really good at, but OpenAI sucks at. There's some tasks that OpenAI is great at, but Mistral sucks at. We really want to pick the right tool for the right job. So in order to do that, we deploy a kind of backend proxy service using what's called Light LLM. That basically, when we send a request into the large language model, Light LLM is able to basically branch out and send it to whichever is the appropriate large language model for that task at hand. So once we kind of have the message and the additional chunk context coming into the large language model, it's going to give an output back to the agent that the agent can then kind of construct an OQL query based on. So based on my question of, which students have peanut allergies, and let's say that I didn't get enough chunks kind of back to get a full answer, the agent is able to dispatch an OQL query that matches the prompt. So in this case, we'll see students were allergens included in peanut. This query is going to be dispatched then to our regular application backend. So the same thing that runs reporting, this query is going to go to. It's going to then on the back end basically turn this simple query into a bunch of arcane database operations that are needed to actually pull the information in efficiently. Once the results kind of come back from our student database, we return them to the agent in a tabular format. So we give back kind of a data table to the agent. And then the agent is able to use that data table that we've given it in order to compose an answer. So if it doesn't have a data table, it's not going to give you back an answer. And if it doesn't have the data table it needs, it's going to ask for the data that it needs. So in this way, we're able to kind of avoid the tendency or the temptation that the model might have to hallucinate new information to answer a question, because it can always search for more information. So it knows if it searches for the information and it can't find it, it doesn't assume that the information exists there, So to kind of continue the example, so let's say that I then kind of ask the agent to draft separate emails to each student, letting them know that the cafeteria may use peanut oil and dessert items. So as we kind of saw in Pete's demo, the first thing it's going to do here is it's going to issue another OQL query. And this time, at first we were querying for students that matched our condition of peanut allergies, and we were grabbing just their last name, first name, grade level, and allergens. But now, because we're refining our data, we're actually going to query over the particular student IDs that had come back in the previous result. And this time, we're going to be looking at the contact person information. So, to answer the same question twice, basically, it dispatched two different queries, fetching different information each time as necessary, kind of as it was proceeding through the process. So, these responses get returned back to the agent. And here's one thing that I just want to call out here. So I think most of the examples that Pete showed were kind of single step things. So I ask an agent to do something, it does it, and then it gives me back a response. And then I ask it again to do something else, and then it does it, and then kind of proceed like that. But our agent can also execute tools in sequence. So in this case, I gave it one command. I said, draft emails to all the families saying X, Y, Z, right? And it realized that it didn't have all the information needed. It needed to get the contact information for students. So first, it's going to do that. But then even before asking me for like more direction, the agent is just going to proceed with the next tool in sequence. It's going to proceed to the next task automatically. So it has issued the query, we give it back the results, and then autonomously, the agent is just going to proceed to the next step, and it's going to start drafting those emails. So this is what we call like so this kind of going from the query to the response to more actions, this is what we would call sequential tool execution, where it's kind of relying on the results of the previous step to kind of move forward to the next step. But you also saw this a little bit in the demo, but we also support parallel tool execution. So in this case, I don't want it to only issue one email. I wanted to draft all of the emails at once in one step. Well, the agent is, in addition to using kind of the tool sequentially to get the information, it's also able to execute multiple actions in parallel. So when we saw kind of the example of calculating the averages over here, so these two counts would be executed in parallel. They'd be executed at the same time in order to get the next step of information. So not only do we support kind of sequential tool usage, one step after the other, but we also support kind of the execution of multiple tasks in parallel. And those two together mean that kind of the agent can take the fewest number of steps required to actually solve a given problem when prompted to do so. I just want to give a kind of brief shout out to our communication system. So kind of as Pete mentioned, you can send messages directly through the agent. And those all pipe into our standard communications framework, which is omnichannel, meaning that based upon the contact information that we have on file for the parent, those messages might go out over SMS, they might go out over email, there's failover, there's retries. Our comm system is very broad and very strong, so I just want to give that shout out now. But yeah, I think that brings us more or less to the end of the diagram. I don't know, Pete, is there anything I think I missed there?
No, that was really helpful, and I think like understanding the details here are useful. Not just another GPT wrapper. Maybe if you could just speak to security a little bit and
Yeah, totally. Yeah, and I think there also might have been a question in the chat that came up about this, asking kind of where the data is going. So, we are very deeply concerned about security and privacy. We maintain SOC 2 compliance, and that doesn't kind of change now that we're doing this new agent thing. So we take this very seriously, and you can kind of see that reflected in our design of the system that role-based access control is kind of baked into the foundations of the system. Like we really take this seriously. And this also, comes into the fore when we're talking about our external partners for this. So as I mentioned, we're multi-model. So we've kind of designed our architecture in a way that allows us to substitute kind of different large language models kind of interchangeably. And what that means is that we're not tied to those like closed source proprietary models that you might be thinking of, like OpenAI or Gemini or even Microsoft's Copilot. Like we're not kind of bound to those closed source systems that involve sending data out of the system. So we actually deploy a couple of open source models ourselves kind of inside of our own infrastructure. So right now we're running both Mistral and Llama kind of on our own hardware, kind of in our own system. Data is not leaving kind of ever because we recognize how kind of sensitive this information is. And I think also kind of embedded in that question was about training. So we use models that are kind of off the shelf. We do not do any kind of fine tuning or training of our model on student data. Student data will never be kind of used in our models. We feel very strongly about this. We recognize that our clients feel very strongly about this. And we're architecting the system in such a way that performance doesn't suffer because we're losing out on that information. So we think a lot about examples rather than fine tuning. So kind of giving the robot scenarios and kind of telling it how it might be able to solve them using the tools it has, rather than trying to actually train it on real input and output, where you might start to see the leakage of information that shouldn't be getting into the general model, kind of ending up there. Yeah. role-based access control is very important, and it's hard to imagine a system like this actually being able to function without kind of drawing like hard boundaries around information access. We recognize that this can be like a little bit scary to see on the first blush, and we want to make sure that we articulate that we've kind of done everything at every level to make sure that kind of information is staying where it needs to. We take it very seriously.
Well, thank you. Well, that's our prepared remarks. Curious what other questions people have and other use cases that you might want to see this against. We're really going back over Blackbaud and Bureaucross's API endpoints and working with our customers to try to find the ones that are most interesting or hardest to currently query. But that's the type of thing. And if it's not in the chat now, if you want to reach out separately, we're really working closely with some of the earliest adopters here on, hey, what else? Because the student support umbrella we've been in is these tools are super useful for that, but we think a lot more too. So we're currently working against the key academic endpoints in Blackbaud, and one thing I'm personally excited about is teacher comments, rich unstructured data, giving folks the ability to kind of ask questions about significant amounts of unstructured data, and then combined with the ability to kind of accurately query the actual grades and assignment scores. That I think is going to be a really compelling combination, and coming to a theater near you very shortly. But any other questions? I know also a lot of folks are on vacation, and so I can give you 13 minutes back. Um, and this is a little bit technical for me. I think that's a database question. Oh, hi, Austin.
Yeah, so we have like a pretty robust system on our back end. A lot of what we do is pulling in kind of the world from Blackbaud every night, kind of restructuring it in a way that our application can use, and then kind of enriching it with our own first-party encounter data and everything else. It's like we've actually been, in order to like expand the scope of kind of what the agent has access to, we've been pulling more data into our core platform. So attendance is something now that we're actually keeping track of kind of in a rigorous way on our side, largely so that the robot kind of has access to that data, above and apart kind of what it may be useful for kind of, through direct access for our users.
I think the short answer to that question is the API.
Yeah.
The API for now, and I know there are like a lot of different ways of getting Blackbaud data out. We've been of an API shop for a long time, but to get as much data as quickly as possible and the things that aren't in the API, we're starting to look at some of these other products they have. Bill, I saw you come on video. I'm not sure if you're going to ask a question.
Yeah, I was going to. I was going to type it in chat, but since you asked, I'll just
Yeah, thanks.
be helpful. So you kind of answered it, but what I was starting to get a feel for is, I know your product, you have some core functionality that that you've been focusing on for a couple of years. Am I hearing that you are actually looking to pull more data through Blackbaud's API in order to allow your agent to do this kind of stuff you just demonstrated for things like you just said, possibly comments and grades, they're not part of your core product, like that's an extra service you're looking to try to get into and provide?
Exactly. Yeah, yeah, it's kind of a, how to say this, we've built a product for the current user base that's broadly applicable in a way that's almost surprising to us. And we're really looking to give the agent more power, and hearing, we've spent a lot of time with the folks that we serve day to day, and it's been a really interesting moment to kind of widen our aperture, talk to some other folks about what their data problems are, and we're early in that journey, but like the tech infrastructure is there. We just need like the right questions from the right folks that are important to a broad group of people and grabbing the right data to make sure that we can answer it. But that's exactly our goal.
Thanks.
Thanks for the kind words, Tina. I appreciate it. Well, thanks so much for coming. I actually didn't expect this meeting to go so long. Thanks for paying attention and being here. So you can always reach out at hello@augustschools.com. Thanks, Austin. I'm Pete at augustschools.com. This is Aaron at augustschools.com. We're easy to get a hold of. We'll all be at the ATLIS conference. Would love to see some of you face to face. And yeah, thanks again for joining. Really appreciate it. And thanks for hosting, Kelsey.
Yes, thanks, Pete and Aaron, and thanks to all of August Schools for all the support you give to the ATLIS community. Can't wait to see you in Atlanta next month. Take care, everyone.
Bye now.